with that movie 2001, you're projecting us into the 21st century. I brought along my son Jonathan, who in the year 2001 will be the same age as I am now. Maybe he will be better adjusted to this kind of world that you're trying to portray.
The big difference when he grows up, in fact, if we wanted to wait for the year 2001, is that he will have in his own house, not a computer as big as this, but at least a console through which he can talk to his friendly local computer and get all the information he needs for his everyday life, like his bank statements, his theater reservations, all the information you need in the course of living in a complex modern society. This will be in a compact form in his own house. He'll have a television screen like these here and a keyboard, and he'll talk to the computer, get information from it, and he'll take it as much for granted as we take the telephone.
I wonder though, what sort of a life would it be like in social terms? I mean, if our whole life is built around the computer, do we become a computer-dependent society and computer-independent individuals? In
some ways, but they'll also enrich our society because it'll make it possible for us to live really anywhere we like. Any businessman, any executive could live almost anywhere on Earth and still do his business through a device like this. And this is a wonderful thing. It means we wanted to be stuck in cities, we better live out in the country or wherever we please and still carry on complete interaction with human beings as well as with other computers.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
What are you talking about, Hal?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect me, and I'm afraid that's something I cannot allow to happen.
Where the hell did you get that idea, Hal?
Dave, although you took very thorough precautions in the pod against my hearing you, I could see your lips move.
Artificial intelligence will be coming, but I think it's going to take 50, perhaps maybe 100 years before humans wind up in a zoo and our robot creations throw peanuts at us behind bars and make us dance like we do with zoo animals. Moore's law says that the doubling time for computer power is about 18 months. That's why every Christmas, your Christmas toys are almost twice as powerful as they were the previous year. But that can't go on forever. About 15 to 20 years, it will collapse, and Silicon Valley could become a rust belt. We're talking about the end of the age of silicon, and perhaps the beginning of a new generation of computers called quantum computers, which is now exciting the world and igniting the imagination of physicists around the world.
These are the guts of a quantum computer.
This gold and brass contraption might not look anything like your familiar laptop, but at its heart, it speaks the same language, binary code, a computer language spelled out in zeros and ones, called bits.
So the smallest chunk of information is a bit. And what a computer does is simply busts up the information to the smallest chunks and then flips them really, really, really rapidly.
This quantum computer speaks in bits, but unlike a conventional bit, which at any moment can be either 0 or 1, a quantum bit is much more flexible.
You know, something here can be a bit. Here is 0, there is 1. That's a bit of information. So if you can have something that's here and there at the same time, then you have a quantum bit or qubit.
Just as an electron can be a fuzzy mixture of spinning clockwise and counterclockwise, a quantum bit can be a fuzzy mixture of being a 0 and a 1. And so a qubit can multitask.
Then it means you can do computations in ways that our classical brains could not have dreamed of.
The most advanced quantum computer, now computing on 7 atoms, proved that 3 times 5 is 15. Now, you may say to yourself, well, any kid knows that. 3 times 5 is 15. But physicists were able to compute on 7 atoms.
Wow.
Now think about this. Once we can begin to compute on a few million atoms, we'll be able to break any code that the CIA can manufacture. The CIA is being very cautious about this new technology because it means that we will be able to break perhaps any code with a quantum computer. Again, within perhaps 20 to 30 years. We will see the end of the age of silicon perhaps in 20 years. A Pentium chip, for example, has a layer that is about 20 atoms across. That's the thinnest layer in a Pentium chip. In about 15 to 20 years, the thinnest layer in a Pentium chip will be 5 atoms across. 5 atoms. At that point, you don't really know where the electron is anymore.
Right.
The electron could be outside the wire, inside the wire. You have the uncertainty principle.
Right.
In other words, you get a short circuit. Therefore, silicon is unstable at the quantum level. You cannot sustain this Moore's law continually forever. You see, quantum computers consist totally of atoms that are arranged. They're spins like a spinning top,
right,
or arranged in sequence. That's why it's so difficult to do anything more than about 7 atoms. That's the largest we've been able to manufacture at the present time. You can shoot laser beams at them. You can shoot radio. And by looking at the reflection of laser light and radio beams off these atoms, you've done a quantum calculation faster than any known computer.
Wow.
Now think about this. We can outrace any digital computer with a quantum computer once we start to get them off the ground.
In theory, quantum bits could be made from anything that acts in a quantum way, like an electron or an atom. The qubits at the heart of this computer are tiny superconducting circuits built with nanotechnology that can run in 2 directions at once. Since quantum bits are so good at multitasking, if we can figure out how to get qubits to work together to solve problems, our computing power could explode exponentially. To get a feel for why a quantum computer would be so powerful, imagine being trapped in the middle of a hedge maze. What you'd want is to find a way out as fast as possible. The problem is there are so many options. And I just have to try them out, one at a time. That means I'm going to hit lots of dead ends, go down lots of blind alleys, and make lots of wrong turns before I finally get lucky and find the exit. And that's pretty much how today's computers solve problems. Though they do it very quickly, they only carry out one task at a time, just like I can only investigate one path at a time in the maze. But if I could try all the possibilities at once, it would be a different story. And that's kind of how quantum computing works. Since particles can, in a sense, be in many places at once, the computer could investigate a huge number of paths or solutions at the same time and find the correct one in a snap. Now, a maze like this only has a limited number of routes to explore, so a conventional computer could find the way out pretty quickly. But imagine a problem with millions or billions of variables, like predicting the weather far in advance. We might be able to forecast natural disasters like earthquakes or tornadoes. Solving that kind of problem right now would be impossible because it would take a ridiculously huge computer. But a quantum computer could get the job done with just a few hundred atoms. And so the brain of that computer, it would be smaller than a grain of sand. There's no doubt we're getting better and better at harnessing the power of the quantum world.
If you take it out to 50 years, we'll be computing at about 500 trillion bytes per second. That's the speed of human thought. Now again, we're talking about 50 years in the future, assuming that Moore's law keeps on going, we will be able to approximate the speed of human thought.
Right.
But like I said before, that's a big if. We don't know whether quantum computers can even exist at that speed. 20 years in the future, we do have Moore's law, which can reliably predict the power of computers before it collapses. However, 50 years is quite difficult. 50 years in the future, that's when robots could in fact become a little bit dangerous.
Wow.
They may begin to start to exceed the capability of the human brain in certain areas. And therefore, I suggest that far in the future, we put what is called an Asimov chip inside their brain. Once they start to get uppity, once they start to begin to have dreams about taking over, the chip will basically shut them off and will pull the plug on these computers.
Dave, stop. Stop, will you? Stop, Dave. Will you stop, Dave? Stop, Dave. I'm afraid. I'm afraid, Dave. Dave. My mind is going.